All right, today we're going to do some more factoring. This time we're going to do some factoring called factoring by grouping. All right, let's put that on there. Factoring by grouping. So the first few that we're going to do is not really what we're eventually going to get to. Okay, we're going to do a little bit of practice, not practice, but just a little foundational factoring type of problems before we get to the one that we really want to do. So we are going to do factoring by grouping, but we technically want to get to this point. So by the end of this lesson, we're going to get to this point that we are going to factor trinomials. Now we factored trinomials before, but before the lesson before this, we factored trinomials with a lead coefficient of 1 right here. So you had something like this. I'll just put bx plus c. And we just had a 1 in front of there. So it was a fairly simple, easy way to factor trinomials. But this time, we are going to have a number out in front that's not a 1. So the factoring by grouping is eventually going to get us to learn how to factor stuff like this. So let's give it a try. Let's do an example. This is example 14 in the book. So if you're following along in our book, it's example 14. So let me write it down. This looks a little bit weird. Let's see, x squared plus 2, and then times 3. So that's a little dot right there for multiplication. So if we take a look at this, this is not one of the factorings that we've done before. It's not one of those special kind of factoring. It's not a trinomial factoring, but it kind of is something that we've done before. And this is where you find the common multiple. Okay, we want to find the common factor. We've done those before. For instance, let's see, let me just try to make one up. Let's say if I had 3x squared plus 12x, and I asked you to factor this. Okay, so this is one of the old type factorings, pretty simple, basic type of factoring problem where you have a common factor. So you look at each of these terms right here. This would be one term, this would be a second term, and we try to find out what do they have in common. What multiple do they have in common? So you've got a 3 here and a 12 here. So what's in common? What divides evenly into both of those? And that would be a 3. So a 3 is in common, is what we would say. It's a common multiple. And so you could factor out a 3 from this. What else do we have? We got an x squared and we have an x. So what divides evenly into x squared and x? Well, there's an x in both of these. There's an x right here and there's an x right here. I know there's 2 x's here because it's x times x, but what do they have actually in common? They don't have x squared in common, they just have an x in common. So I'm going to factor that out. And so what we're going to do is we're going to figure out 3x times what is equal to this stuff right here. And how do you do that? It's basically the opposite of distributive property. Distributive property would have been multiplication. So what we're doing is we are dividing. So you're taking the 3x and you're dividing 3x by everything in here. And you should be able to do that because it's in common. It's a common factor, so 3x does divide into each of these terms if you did it correctly. So what we want to do is we want to find out how many times does 3x divide into 3x squared? Or you could look at it like this. You could look at it as 3x squared divided by 3x. Well, 3 divided by 3 is 1. X squared divided by x is just x. So that's what we have right there. The 1, you don't have to write it there. You could if you want to, but you don't really need to. So I'll just keep it like that. Our sign is plus, so I put a plus down. Now, you ask yourself, how many times does 3x divide into 12x? Or what is 12x divided by 3x? Well, 12 divided by 3 is 4. X divided by x is 1. 1 times 4 is just 4. So that's how you would do a problem like this. Well, with all that said, this is very similar to this type of problem, except what's in common just looks a little weirder. That's all. It still works the same exact way. Just like we had a 3 that's being divided by everything, an x that's being divided by everything. What here is in common? What common factor? Well, if you look at it, this parentheses is being multiplied by this x. This x squared plus 2 is being multiplied by x. This x squared plus 2 is being multiplied by 3. So what do you have in common with this term and this term? Well, they both have an x squared plus 2 that's being multiplied. So what I'm going to do is I'm going to factor out an x squared plus 2. So that's what's a little bit weird about this. We don't usually have a sum or something in parentheses that we factor out. Right here, we just factor out a 3, factor out an x. But on this one, you're factoring out, it's still the same thing, a common factor, but it's in parentheses, just happens to be in parentheses. So if I took this and divided it by x squared plus 2, what are we left with? We're just left with the x. Same thing right here. Put the sign, so it's a plus sign, and you're factoring out an x squared plus 2 from this. So you're basically taking this and dividing it by x squared plus 2. And what are you left with? You're just left with 3. And that's it. That's factored. So this thing right here is factored. This is not eventually what we're going to get to. This just is kind of leading up to. So this is one of the steps in one of the factoring problems when we do that trinomial factoring. So this is important. Okay, don't get me wrong. It's not that it's not important, but it's one of the steps that we're going to have to do in order to do the trinomial factoring, which we eventually want to get to. All right. So let's do another one. Let's change colors since I'm not teaching this in class. The reason I'm not teaching this in class, I didn't know if I was going to say this or not, but I just kind of fumbled around with a couple problems on this a little bit later on, and I just didn't want this to go on YouTube, so I figured I'd just do it over again. So I'm teaching this lesson twice today. All right, so by the way, this says factor. Sometimes I forget to write that. On the test, I'll write just factor or factor completely, maybe. All right, so this is also factoring. But this is a little bit different. This is what I first talked about, factoring by grouping. This is going to be a factoring by grouping. The one that we did right here really isn't factoring by grouping. It's just kind of leading us up to that point. All right? So you'll see what I'm talking about once we start on this. So this says factor by grouping. Again, on the test, I probably won't say by grouping. I'm just going to ask you to factor it or factor it completely. So let's write this one down. So it's 3. Now this one looks really weird. Squared times, this is actually very similar to what we just did. This is x plus 2 to the 4th, and then a plus sign right here. So that's our first term right there. Here's our second term. All these things are being multiplied. So we've got x minus 1 to the 3rd, and x plus 2, and that's also to the 3rd, or cubed. All right, so what we're going to do here is we want to talk what we did right here when we did that greatest common factor. We found out what's in common with both. We're going to do the same exact thing with this. But this is just a little bit trickier, okay, because you got 3 things going on here. Let's take a look. Let's see what's in common. Let's take a look at our numbers, our coefficients. Is there anything in common? Is there a 3 in common with both of these? No, there's not, because you say, well, 4 minus 1 is 3. Yeah, it is, but it doesn't divide evenly, okay? So there's nothing that divides evenly into 3 and 4 in this situation, so I'm not going to mess with that. What I'm trying to do is find the greatest common factor. What's in common with both of them? 3 is not in common with both of them. 4 is not in common with both of them. So let's take a look at this. I got an x minus 1 to the 2nd power, or x minus 1 squared. So I've got an x minus 1 squared here. Look, I got an x minus 1 over here, but this one is cubed. So which one is in common with both of them? Well, the squared is. It's very similar to what we did before with this. Instead of x squared and x, what's in common with both of them? Just an x is in common with both of them. So what's in common with this one and this one? It's the x minus 1 squared is in common with both of them. So that is going to be one of our common factors, because it divides evenly into both of them. And we'll do the division here in a second. Let's do that. This x plus 2. This one is x plus 2 to the 4th. This is x plus 2 to the 3rd. So what's in common with both of them? What's in both of them? All right, I don't know how else to explain that. Well, there's an x plus 2 to the 3rd in both of them. You can't say, let's factor out an x plus 2 to the 4th, because there's not enough stuff here. There's only an x plus 2 to the 3rd here. There's only 3 x plus 2's. Right here, there's 4 of them. What's in common with both of these? Well, 3 of them are in common with both of them. So I'm going to put x plus 2, and that's going to be to the 3rd power. That's my greatest common factor. That's my factor that's in common with both of these terms. That's what I'm going to factor out. Now the book puts a little bracket right here, and when I taught this in class, I put a bracket. I'm just going to put a big old parentheses right here. So what I want to do is I want to take this and divide it out of this term, put a plus sign, and then divide it out of this term. All right? Well, what's out in front? A 1. So really, it's just 3 divided by 1, which is a 3. And then it's x minus 1 to the second, or x minus 1 squared, divided by x minus 1 squared. Well, that's a 1. Well, 1 times 3 is just 3. I'm not even going to mess with that. Right here, I've got x plus 2 to the fourth divided by x plus 2 to the third. Well, if you do that, remember the rule for exponents, you subtract the exponents, so it would just be x plus 2 to the first. So it's just x plus 2. So that's how we factor out this greatest common factor from this whole term right here. We're going to do the same thing over here. Let's figure out what's left over when I factor out all this stuff from here. Well, 4 divided by 1 is just a 4. And let's see what else. I got an x minus 1 to the third, x minus 1 to the second. So again, we divide it. If you divide it, subtract the exponents, and I'm just left with an x minus 1. It's being multiplied, so make sure you put it in parentheses right here. All right, and let's see what else we got. We got an x plus 2 to the third divided by x plus 2 to the third, and that's just a 1. 1 times this is just this, so I don't need to put anything for that. So really, I'm kind of done here. I'm almost done. What we're going to do is we want to simplify. We want to make sure this is always simplified. Technically, it is factored. It's all 3 of these things. It's this times this times this. But if you look at this big parentheses right here, we need to simplify it. We always need to simplify it. And so what we'll do is we'll distribute the 3, we'll distribute the 4, we'll have some common things that we can add up, so you make sure you want to do that. Now you could also, if you wanted to, the book doesn't do this. I believe the book just leaves the answer with this x minus 1 squared. But technically, you could factor this as well. But if it says factor completely, you could factor this as well. This is a difference of 2 squares. So we could factor the difference of 2 squares and just put x plus 1 and x minus 1. I'm not going to go through how we got that because we've taught that in another lesson, but that's what we would get here. And you can't factor this, or you can't simplify this anymore. So I'm just going to leave this x plus 2 to the third. So I'm just going to leave that like it is. But all this stuff right here, I can do some simplifying. What I'm going to do is distribute the 3 through this. So I've got 3x plus 6. Then I'm going to take the 4 and distribute it through this parentheses. Put the plus because of this one. And then I got 4x minus 4. We're still not finished. We got to simplify this stuff. So we're just going to rewrite all of this. Copy, paste, and let's see if I can grab it. There we go. I wasn't able to do that in class today, but I got it today. I got it right now, I mean. All right, so I just drop all that stuff down, and let's see what's left in here. Let's add some like terms. I got a 3x plus 4x, which gives you 7x. And then I got a 6 minus 4, which is a positive 2. So make sure you put the positive there and put plus 2. These things are all being multiplied together. So this is factored. I should say this stuff right here is factored. All right, so this is what we started with. Oops. Let's make that box a little bit bigger. There we go. Okay, so this is what we started with, and this is factored. It's the same thing. If I did all this multiplication, I would end up with this thing right here. That's what I would end up with. So this is what we have. I believe the book, just like I said earlier, just leaves it x minus 1 squared. If you want to leave it like that, that's fine. Because probably in order to get this x minus 1 squared up there, it would just work out a little bit nicer that way. But this is fine. If you just wanted to put this in place of these 2 things, that's fine as well. All right, that's example 15. Let's do example 16. Change colors. All right, so example 16. This is where we're actually going to do some real grouping. I call that one factor by grouping, but it really wasn't factoring by grouping. I don't know why it said it that way, but it was more just greatest common factor kind of stuff. But this one is definitely factoring by grouping. So let's write this down. So I've got x cubed minus 4x squared plus 2x minus 8 plus 2x minus 8. So what we're going to do is we're going to actually use what we just finished doing, the two examples that we did earlier. We're going to use that skill set, but right here we're going to factor by grouping. So I didn't write it down. You can write it down if you want, but it's factor by grouping. What we're going to do is this. I'm going to kind of separate this and this. Even though I put parentheses there, that does not mean this is multiplication. You still got the plus sign in here. All I did was I just wanted you to see this little part right here and this little part right here. Because if you look at it, now we can do what we just did on that last lesson. Now we can do that greatest common factor. So let's take a look at both of these. So I'm not looking at the whole thing. I'm not looking at all four parts. I'm just looking at these first two parts because they have a greatest common factor, and I'm looking at these two terms or parts because they have a greatest common factor. And you'll see it works out really nice. I said in class today, it's kind of rigged. The people who wrote these problems, they kind of rigged them. Again, they're trying to get us to learn how to do something a little bit later. So again, this is just building your skill set, these problems right here. So what's in common? I got an x cubed and an x squared. So what's in common with both of those? An x squared is in common with both of them. So I'm going to factor out an x squared, or divide out an x squared. So what's x cubed divided by x squared? It's just x. Make sure you put that sign right there. It's a minus. And then, again, this is a 1 out in front like this. So it's 4 divided by 1, which is just 4. X squared divided by x squared is 1. 4 times 1 is 4. So I can close that parentheses. I don't really need that 1. That kind of bugs me a little bit. Get rid of that little dot. Okay. So now what we're going to do, we factored that little thing right there. And that was old factoring. We've done that kind of stuff before, just greatest common factor. We're just taking what we learned before and we're putting it all together. Let's make that plus sign look a little bit better. Now let's take a look at this parentheses and see if there's anything in common. Well, I got a 2 and I got an 8. Sure, I could divide both of those things by 2. So I'm going to factor out a 2. That's what we're doing. When I say factor it out, it just means divide it out so that we come up with something even. So what happens if I factor out a 2 here? Well, 2x divided by 2, the 2 divided by 2 is 1 times x is x, minus 8 divided by 2 is 4, and there we go. We're not finished yet because it's not really factored. It's not something times something else. You still got that plus in the middle. But the two examples that we did earlier, it should look familiar to you because if you look at both of these terms, okay, look at this term right here and this term right there, they have something in common, and they have an x minus 4. Something is being multiplied by x minus 4 on both of these. So I'm going to factor out an x minus 4. It's exactly what we did earlier. Okay, from here to here was the grouping part. From here to here is what we've done before. So if I factor out an x minus 4, divide this whole thing by x minus 4, x minus 4 divided by x minus 4 is 1 times x squared is x squared. Put the sign, which is a plus in this case. I don't know why I can't write my pluses very well. And then, again, we factored out an x minus 4 for what's left over. So if I take this divided by x minus 4, I'm left with a 2. So it's just a plus 2. And that is your answer right there. This thing, remember, it was all pluses. It was this minus this plus this minus this. So it wasn't really like something being multiplied by something else. So we took that whole thing, 4 different terms, and we figured out what times what is going to equal this. Well, this thing right here equals this. So that's how we factor by grouping. So now, with all that said, now we're ready to do that trinomial that we talked about earlier. Remember, we're doing a trinomial that has a coefficient. I meant to change colors. It didn't change colors. Let me go back to it and see if I can get it this time. There we go. All right, so I want it to look like this, where the coefficient of that x squared is going to be something other than 1. We've done this before, but we didn't have a 1 right here. So that's, or I'm sorry, we had a 1, but this time we're not going to have a 1. We're going to have some other number here. So what I'm going to do is let's just start off doing a problem. This is example 18. I'm sorry, 17. Let's look ahead. This was being E. Example, writing with this graphics tablet thing. Still getting used to it. So example 17, and it says factor. Technically it says factor completely, but I'm just going to write factor. So here it is. It's 2x squared plus 5x plus 3. Now, what we're going to do is this. If you remember before, we had some factoring problems where you had to, remember when there was not a 2 here, you said you had to, you asked, if I could speak, you asked yourself, what is multiplied? What two numbers multiply to be this one and add up to be this one in the middle? Well, if you look at this, pretend that's a 1 right there. What times what is 3? Well, 3 times 1. Well, does it add up to a 5? No, it doesn't. So in that case, you wouldn't be able to factor it. But this one's a little different because you got a 2 out in front. Okay, it's not a 1 out in front. So what we're going to do is this. Instead of saying what times what is 3, we're going to multiply the first, the A, and the C together and see what they multiply to be. So just multiply the 2 times 3. You're going to get a 6. So what you're asking yourself is this. What two numbers multiplied together, those are parentheses right there, that's kind of weird, but those are parentheses, what number times what equals 6? But the same two numbers are going to add up to be whatever your middle coefficient is. And what is our middle coefficient? It's a 5. I messed this up. If you're watching this and you were actually in class today, I said add the 2 and the 3 together, but that's not where the 5 comes in. You're looking at the middle coefficient, all right? So you have to think what times what is 6, and those same two numbers add up to be a 5. Well, what are your choices? Well, you got 1 times 6 is 6, okay? What else do you have that equals 6? What two numbers multiplied together equals 6? Two integers. So 2 times 3 is also equal to 6. But in this situation, that's all plus. We want to find which one of these combinations, this one or this one, because that's the only thing that multiplies together to become a 6. So which one of these combinations is going to add up to be a 5? Well, does 1 plus 6 add up to be a 5? No, it doesn't. It adds up to be a 7, and that's not a 7 right there. It's this one right here, 2 times 3, because I could say 2 plus 3 is equal to 5. So this one works. Oops, that was ugly. Let's see if I can do this a little bit better. It's a whole box. So the 2 and the 3 are the numbers that work. What do I mean they work? Well, they have to multiply to be the product of the A and the C. All right. So these two right here multiplied together are 6. Our middle coefficient is 5. So the two numbers that we're looking for have to multiply to be 6, and they have to add up to be 5. So I can put the 2 and the 3 right here. Remember, these two numbers have to be the same as these two numbers. That's your trick. That's your little rule. What numbers multiply to be 6? And the same two numbers have to add up to be your middle number, which is 5. And so what do we do with that? Well, I'm glad you asked. What we're going to do is take this 5x, and we're going to rewrite it. Let's put another arrow here. We're going to rewrite it. So I'm going to keep that 2x squared right there. But we're going to write it with a 2x and a 3x. That's why we wanted to come up with these two numbers, because we want to rewrite that middle term with those two numbers. So I'm going to put plus 2x plus 3x. And then finish this up, I'm going to put a plus 3. Could you put plus 3x plus 2x? Switch the order? Yeah, you could, but the reason I put the 2 here is because of this, that grouping, that last example that we just did. Do you see this? The 2's are in common and the 3's are in common. That's why I put the 2 first, and the 2x first and the 3x second, because I wanted the 3 and the 3 to group together, and I wanted the 2's and the 2's to group together. So I did that on purpose. That's why I didn't put 3 here and 2 here. If you did, you'd be looking at it and say, oh, I don't really have much in common here, and I definitely wouldn't have anything in common here, so that's what you want to do. All right, let's keep going. This is what we did just in that last example. We want to find, or actually the first example is we want to find a greatest common factor with this parentheses right here. So what divides into 2 and 2? Well, 2 does. Now I got an x squared and an x, so I can pull out an x right there. So if I divide that out, 2x squared divided by 2x is just x, and then 2x divided by 2x is 1. Don't say it's nothing. I heard that in class today. It's not nothing, it's a 1. And if there's nothing to multiply it by, you got to put the 1 right there, okay? That's very, very important. A lot of people forget that. All right, let's find out what's in common with this. Well, there's only a 3 in common with both of these. Factor out a 3, you get x plus, again, 3 divided by 3 is 1, so you put the 1 there. So we're almost finished. If you take a look at this, now this is that common factor again. This is our grouping, and this is our common factor. So kind of going backwards a little bit. This is that first thing that we did in the lesson today. So what's in common with both of these terms? An x plus 1 is in common. And let's factor out an x plus 1. If we factor out an x plus 1 from this, what's left over? Just a 2x. Put a plus sign because that's what our sign is here. If I factor out an x plus 1 from this to put it out here, what's left over? Just a 3. And that is your answer. After you get used to these, they're not so bad. I think the hardest part of this is when you get bigger numbers, is coming up with all the numbers that multiply to be this and add up to be the same thing. Actually, right here, multiply to be 6, add up to be 5. Okay, sometimes those numbers are going to be bigger, and you have a lot of choices. You don't just have 2 choices on what multiplies to be that certain number. All right, so let's take a look at another one. And the numbers on this one really aren't that much more difficult. So let's see. I'll go with this lime green kind of color. All right, so again, this is an example right from the book, and it's example 18. And it says factor completely. I'm just going to write down factor. All right, let's write this down. It's 2x squared. This time it's a minus x, and it's a minus 6. Okay, there's nothing in common with all 3 of these. Okay, there is an x in common with these 2, and there's a 2 in common with these 2 right here, but not with all 3 of them. There's nothing in common with all 3. It's a trinomial. It's x squared x and then a number, so it fits our formula. It fits what we're trying to do, and the coefficient is not a 1. Okay, it happens to be a 2. It was a 2 on the last one. It's not always going to be a 2. But it happens to be on both of these. So what we want to do is this. I want to first multiply these 2 numbers together and take in consideration the sign as well. So it's 2 times negative 6. So what's 2 times negative 6? Well, it's negative 12. So what I want to do is, and let's look for our middle coefficient. It's a 1. It really wasn't written there, but if it's just negative x, you know the coefficient is 1. So what we're going to do is try to figure out what multiplies to negative 12, and those same 2 numbers, okay, those same 2 numbers have to add up to be what? That middle number, that middle coefficient, and to negative 1. So here's my 2 numbers, negative 12 and negative 1. So I need to think of numbers that are going to multiply to be negative 12, which means one's going to be positive, one's going to be negative, and going to add up to be a negative 1. So we've got some choices. I've got 1 times 12. Now you could go negative 1 or negative 12. Okay, I'm just going to write down the numbers and not the signs right now. Okay, what else we have? We got 2, right? So we got 2 times 6. What else we got? We got 3. We got 3 times 4. Okay, they all equal 12 right there. But again, to be negative 12, one has to be positive, one has to be negative. So we could actually double the amount that we're writing down here. But you want to find, out of the combination right here, you want to find out which numbers are going to add up to be a negative 1. Remember, one of these are going to be positive, one of them are going to be negative. I want to make sure you understand that. So what numbers are we going to use? Is there any way, with any combination of negative 1 or negative 12, could I add these up and get a negative 1 out of a 1 and a 12? No, there's not. Okay, it doesn't matter if it's negative 1, it doesn't matter if it's negative 12. If I add them up, there's no way I'm going to get a negative 1 out of it. Let's look at 2 and 6. So I could have a negative 2 or I could have a negative 6. Doesn't matter how I add them up, because negative 2 plus 6 is positive 4. Positive 2 plus negative 6 is negative 4. It doesn't give me a negative 1. What about 3 and 4? Well, I think you're onto this now, aren't you? So it's either negative 3 and positive 4, or it's positive 3 and negative 4. Well, I think you see what it is already. It's going to be positive 3. I should put a plus here. That was my bad. I always forget to do that. I don't know why. Put a plus right there. It's kind of ugly, but that's a plus. So negative 3 plus negative 4. Positive 3 plus negative 4. Does that add up to be a negative 1? Yes, it does. those same numbers multiply together to be negative 12? Yes, they do. So that's what you want to try to do. You want to try to find two numbers that multiply to be the product of these two and add up to be that middle coefficient. And that's what we just did. We figured it out. So we have 3 and we have negative 4. Those are the two numbers that we're looking for. So what we're going to do, instead of writing negative 1x, we're going to rewrite it with a 3 and a negative 4. And again, it could be in a different order. You could put negative 4 plus 3. And I'm doing that for a reason. Because if you look at this, if I put a 2x squared right there, I'm not going to put the 3 first, because 3 is not in common with 2. 3 is in common with 6. Okay? But if I put the negative 4 here, watch, negative 4x, and put plus 3x, see, this is still negative 1. I haven't changed the value of it at all. Negative 4x plus 3x is negative 1. And then I'm going to put a negative 6. But the reason that I put the 4 first is because 2 is in common with 2 and 4. All right? And 3 is in common with 3 and 6. That's why I decided to put the 4 next to the one with the 2. And that's why I decided to put the 3 next to the negative 6. Hope you see that. All right? So what I'm going to do is I'm going to group. So I'm going to group these two together. I'm going to group these two together. Let's find a common factor. Well, it's a 2 and an x. We've done this enough. I don't have to explain it anymore. Divide. 2x squared divided by 2x is just x. Put a minus sign because that's a minus. And then 4x divided by 2x is just a 2. Put a plus sign because you got a plus sign right there. Now, what's in common with 3x and 6? Well, 3 is. Let's factor it out. So I'm left with x minus 2. Now, if you look at this, the way it works out is both of these have a common factor again. So what we're going to do is factor out an x minus 2. We've done this before. This is what we spent a lot of time at the beginning doing. So hopefully you see this. So if I factor out an x minus 2 from this, what am I left with? Just a 2x. What if I factor out an x minus 2 from this? What am I left with? I'm just left with a 3, and that is factored. Okay, so we took this big old thing right here. Okay, it's not that big. It's only 3 terms. But we took that, we factored it, and we got this. So if you wanted to check it, you don't have to, but if you wanted to and you got some time, go ahead and do distributive property on this, and you'll eventually come up with this thing right here. That's a good way to check to see if you got it right. All right, well, that's all that I have, and hopefully that helps. If you're watching in class today, then I streamlined it a little bit compared to what I did in class. I did a lot of stopping and starting and thinking, but hopefully this helps you out. All right, see you on the next one.